Okay, we're moving on to Unit 11, Lesson 6, and we're talking about the falling object model. And your objective is there, so let's go ahead and get started. Okay, this is the falling object model. Okay, it's an equation, and what it means is that we can figure out some different things about an object if it is dropped. Okay, and h is its height at any given point in time in feet. Okay, so it could be after or at when it starts. It could be at 1 second, 2 seconds, 8 seconds. Doesn't matter. But this is the height that it is currently at in feet. The t is the time that's gone by in seconds. Okay, so again, this could be after 1 second or 2 seconds or 1.5 seconds or something like that. And then this s is the starting height. Okay, the height that the object actually starts at when it's dropped. Okay, and again, this is for an object that's falling, okay, not an object that's thrown, but an object that's been dropped or has started with no velocity, okay, so we haven't thrown it or anything like that. And again, this is the equation. H, the height in feet, equals negative 16 times t squared, okay, and that's the time in seconds squared, plus s, the starting height. The reason this is negative 16 is because that's the coefficient for gravity, okay, meaning that the height is going to be going downward, okay, at this speed every second. Okay, and this is the falling object model, so let's go ahead and get started. Okay, this says Mr. Ayers is riding the Space Shot at Adventureland. Okay, Adventureland is a theme park in Des Moines, Iowa that I used to like to go to. And the Space Shot is one of those rides that shoots you up really high. Okay, it says he puts a penny on his hand, and at the top of the ride, the penny comes off and he doesn't catch it. Okay, what we used to like to do is when we went on this ride, because it shoots you up so fast, the penny, if you stuck it on your hand, would stick to your hand, and at the top it would like hover there for a second. You had to try to catch it before it hit the ground. Okay, so let's say I put the ride on the top of my hand, it comes off, and then I don't catch it. It says the Space Shot is 235 feet high. I'm asking how long will it take the penny to hit the ground? And we're going to assume that there is no air resistance. Alright, and then this says write your answer as a radical, and then we want to round it to the nearest tenth. Okay, so the first thing we need is we can figure out this is a falling object model. Okay, the penny is going to come off my hand. I'm not throwing it. Okay, it's going to come off my hand, and it's just going to drop to the ground. So we need our falling object model. And again, the falling object model is the height at any given point in time is equal to negative 16 times the time in seconds squared plus the starting height. Okay, so things we need to know here. Okay, this says the Space Shot is 235 feet high. Well, that's going to be my starting height. Okay, so 235 feet is going to equal my s. It says how long will it take the penny to hit the ground, so we're trying to figure out t. Okay, well that means we have to know h. Now let's stop and think about this. If the penny hits the ground, that means that there's no height to it. So h is going to be 0. Okay, because 0 is going to be the height off the ground at the end of the problem. So again, the height is 0 because we're going to be 0 feet off the ground. So now I'm going to plug in what I know. I know the height is going to be 0 feet, and I want to figure out how many seconds it's going to take for the height to be 0 feet from the ground. So I'm going to put negative 16 times t squared plus my s is 235. Okay? Well, our job is to solve for the t. So I'm going to start by subtracting 235 from both sides. And I get negative 235 equals negative 16t squared. Now it's a good thing this number is negative because I'm going to have to divide by negative 16. So a negative divided by negative is going to give me a positive. So I got negative 16. And I'm going to have negative 235 divided by 16. Okay, so that's that's going to be positive 235 over 16. That can't reduce, equals t squared. Okay, now I want to solve for t. So I'm going to take the square root of that. So t is going to equal the square root of 235 over 16. Sorry, that should be a big square root. So again, we've learned that we cannot keep this like it looks. We have to break it apart. So t is going to equal the square root of 235 all over the square root of 16. So t equals the square root of 235 all over 4. Now I could try to break down 235, okay? But the only things that go into it are 47 and 5, and neither one of those are perfect squares. So this is my answer as a radical, square root of 235 over 4. Alright, well now I want that answer to the nearest tenth, so now it's okay to use my calculator, and I'm going to take the square root of 235, which is about 15.3297, and then I'm going to divide that by 4. And I get 3.83, so my time is about 3.8. Okay, if I round it to the nearest tenth. So that's going to be about 3.8 seconds. That's going to take that penny to hit the ground, according to my falling object model. And I want to go back to this, the height here. Again, the height was 0 because we're trying to solve for the time when it hits the ground. So when it hits the ground, the height has to be 0. Alright, let's go on to another problem. Okay, problem 2 says Mr. Beeson is 6 feet tall. If he is standing at the bottom of the ride because he's too chicken to go on, how long would that same penny take to hit him in the head? It says write your answer as a radical and then round to the nearest tenth. So now I want to figure out how long it's going to take to hit Mr. Beeson in the head instead of hitting the ground. So again, I'm going to put my height equals negative 16 times t squared plus the starting height. Well, it's the same ride, so the s is 235 feet. I'm going to try to solve for the t, okay? So I need to know the h. Well, now instead of hitting the ground at the end, it's going to hit Mr. Beeson, who's 6 feet tall. So h is now going to be 6. And now I'm going to plug in what I know. Mr. Beeson's height, that we need to have the penny hit him in the head, is equal to negative 16 times t squared plus 235. So I'm going to subtract 235 again. I'm going to have negative 16t squared. I'm going to have that equal to negative 229. Then I'm going to divide by negative 16. So I get 229 over 16 equals t squared. So t is going to equal the square root of 229 over 16, which is the square root of 229 over the square root of 16. So that's the square root of 229 over 4. So t equals the square root of 229 over 4. Now again, we can try to break down 229 if we really wanted to. Okay? But 229 does not have any perfect square factors and cannot be broken down. So we are done. That's as far as we can simplify it. But now again, we don't want to say it's going to take that many seconds, okay? So we're going to want to round this to the nearest tenth. So again, it's okay to use my calculator. I'm going to take the square root of 229, which is about 15.1327, and I'm not going to round it off yet. Okay, I'm going to take that answer and divide it by 4. Okay, and here I get t is about 3.78. So again, that rounds off. It's still going to take about 3.8 seconds to hit Mr. Beeson in the head. Okay? So again, it's about 3.8 seconds. So that 6 feet doesn't make a whole lot of difference. But it makes the problem a little funnier. Okay? Well, that's your problems on the falling object model. I got one bonus problem for you just for fun. Okay? We'll throw a little science in here. This problem says that the penny falls approximately 3.8 seconds before hitting Mr. Beeson. I want to know what's the velocity of the penny when it makes contact with Mr. Beeson's head. Well, here's a formula for velocity. Okay? It says the distance the penny travels equals the velocity times the time. Well, we know the distance it had to travel to hit Mr. Beeson's head was 229 feet. Okay? And we're going to take the seconds, 3.8, times the velocity to figure out what the velocity is. So by dividing by 3.8, okay, if I take 229 divided by 3.8, that means that the penny was traveling about 60.3 and that's feet per second when it hits Mr. Beeson in the head. Okay, that's pretty fast. It's going to hurt. Probably do some damage to him. So lesson learned, do not drop pennies from the top of the space shot because it might hurt somebody. Alright, so that's your lesson on the falling object model. Again, this last one was just a bonus problem. You don't need to worry about that. Just a little science thrown at you. Other than that, good luck on your homework.